Welcome to the lecture on people-centered sustainability transition. Here we want to talk about the end of the energy service cascade, the consumption of people, and the benefit and the well-being consumption generates. We see in Western countries a major surge of consumption, often linked to specific lifestyles over the last decades, illustrated here by this guy whose hobby apparently is skiing. And today, the hobby of skiing would entail much more equipment than it used some decades ago. And all this equipment can be bought because we have the money to do so. And often it is not used very effectively, right? So many things are bought, they're not lasting very long, or they're not used very intensively. So we can look at this problem of consumption. Some people would call it overconsumption at the individual level, but we can also look at how this consumption is distributed across society. And this research topic is called social metabolic inequality, the inequality in consumption across society. This is a major challenge of our time because inequality drives consumption to keep a status. It lowers the social mobility because some consumption levels are expected to be part of a certain socioeconomic group. It can also negatively impact the trust, safety, or well-being of people in places where social mobility is low and there is the idea or the feeling that people who don't have enough are also not fully part of the society. And this type of inequality not only can be measured in monetary terms, income and wealth, but also in non-monetary aspects. And this is the social metabolic inequality. It refers to the inequality in the use of energy and material flows, the access to and ownership of assets like building space or infrastructure, appliances or vehicles like passenger cars, and the consumption of services generated from these assets. And you see some challenges here related to inequality. This could be overcrowding, or it could be lack of living space in general, and also lack of access to transport. Where at the same time, we have huge traffic jams in some cities that can also be detrimental to well-being. So we have these inequality in benefits, services, stocks or assets, and inflows that we want to look at when we talk about people-centered sustainability transitions. We can also look at this problem from the point of why we consume. So we can span the consumption spectrum from two ends. One is the basic needs that need to be met for everybody to have a good life, some basic food, shelter, and mobility and communication. And we have the luxury goods on the other end that are clearly used to communicate a certain status. And in between, we have consumption that is driven by mostly cultural factors. There's, for example, the needs and wants, like, for example, motorcycling, which is a clear expression of a personal lifestyle. So you define your personal needs and wants, and then you consume accordingly. There's also the group of habitual consumption in a given system. So we have cultural norms, technology, and provisioning system, and all of this is available. So of course, in many Western states, it's clear that doing things by car is the easiest. It's also widely possible and accepted. Frequent flying is possible. Having large appliance collection in households is possible. Having your own kitchen and all of these things, we don't think about it often, and they are part of our habitual consumption. There's also the group of rebound effects. Rebound goods are goods that are detrimental to your well-being, but they're necessary to keep your status or to fulfill other needs. For example, commuting. So you have to commute to keep your job, but also to keep your house and circle of friends. So suddenly you find yourself 2 days on the road each day. Definitely not good for well-being, but part of the consumption habits. And it definitely is linked then also to energy and space and material consumption. So you can think about yourself, why do we consume? What are good examples? And how also would you see inequality can be seen in the access to these different consumption groups? When we look at the planet, we see that we have some ecological ceilings, often framed as planetary boundaries, and we also have a social foundation. We have these basic needs that need to be met for people to have a certain level of well-being. And in between, we have what we could call the safe and just space for humanity. So it has a social foundation, basic needs are met, and some habitual consumption and needs and wants are being fulfilled. At the same time, we respect global ecological ceilings. This can also be called a donut economy because it has these double constraints, the social and the environmental constraint. In our field, social metabolic research, we would add detail to this donut. We would define different steps in an energy service cascade where we have well-being of societies and of people as one end here on the left, and the ecological ceilings or the thriving of ecosystems and global ecosystem provisioning system on the right end. And in between, we have these different stages that we use. This is our economy that we operate to generate well-being by using natural resources. The first step is that we need certain services and activities that generate benefits, housing services, mobility, communication, and these services are delivered by the functioning, the operation of stocks. The vehicle is driving, this gives the service of access or mobility, and the stock that is being operated, the building that's heated or the car that's driven, doesn't come out of nowhere, right? It needs build up in energy. At one point, somebody needs to build the car and the steel, and it also needs operational energy. These energies come from the industry, the energy supply, the material production industries. And then you have the mines and the oil wells and the forests that deliver the material and the energies. And in this industry, you can have material cycles, maybe a circular economy, maybe a more make, use, dispose economy. But you see, we can look at these individual elements within the blue elements here within the donut. And we do this because we see here this different coupling between the elements, and all of these couplings provide decoupling opportunities. We can have less services for the same benefit. This would be sufficiency, or we could switch the energy supply. That would be a low carbon energy. So different decoupling options are possible within this cascade. We will look at this at the moment. And we see and we know also from research that we need, for a deep sustainability transformation, to consider both ends of the spectrum. We need demand side strategies for decoupling, and we need supply side strategies for decoupling. So demand side strategies, these are the people-centered strategies. Energy efficiency of end-use good, shared use, increased lifetime and repairability, shift to less energy-intensive provisioning modes like different transport modes, for example, or maybe avoiding demand for certain services via lifestyle changes in the first place, so reducing rebound consumption, reducing habitual and needs and wants, and also, of course, luxury consumption. And this is matched by supply side strategies that are currently predominantly promoted in the sustainability transformation. This would be the industrial energy efficiency, renewables and low carbon energies to fuel change, or carbon capture and storage technology. And again, it's not saying either or, it's saying we need both. We'll come back to this in a minute. We can take the demand side strategies and group them. We can say there's technological options, behavioral options, there's price-driven strategies, regulatory-based strategies, and there's circular economy strategies. Some examples are shown here in this lecture recording. I won't go into details for all of them, but it's clear, for example, that regulation can help with building zone, for example, the number of floors of building, the mix of building, that has huge impacts on transport demand, for example. Behavioral changes could be new, different diet changes, prices, carbon taxes, typical examples. So we have different options at the different stages of the life cycle of this energy service cascade. So behavior can both be on the demand side, for example, a dietary change, but it can also be closer on the efficiency side, for example, by purchasing energy efficient products. So you see we have this table, this matrix structures, different stages of the energy service cascade and different types of strategies. Generally, we group them into avoid, shift, and improvement strategies, which we have here, the sufficiency, changing, and efficiency columns. And this avoid, shift, improve option has its origin in transport, but can be also applied to other sectors. For example, in buildings, we could say if we have a passive house retrofit that even with accepting a lower indoor temperatures, that's avoiding solution. Typical shift solution would be heat pumps. You shift the energy carrier and improve. This would be more higher efficient devices, heating devices or cooling devices. So these are the strategies that are people centered because it's the people who need to decide based on their settings, but also based on alternative provision modes, what services, what consumption patterns can be avoided, where a shift is possible or desirable, and where can we improve. So this is the left part of the energy service cascade. And these strategies are then matched by industry strategies that actually provide more efficient products that also shift energy carriers or that do recycling for circular economy and resource efficient and low carbon material supply. For demand side solutions, we have a number of key research questions because it's easy to talk about them here. It's important, but more important is it to understand their potential and understand how they could possibly be implemented. So we have a missing strategy that needs a more transdisciplinary approach to identify the mitigation potential and also the implications of well-being. Working with practitioners, with incentives that try to do this, getting data and study how these different strategies, we had them here, the technologies, the regulation, and so on, can be rolled out in different cities so that they will actually contribute to high levels of well-being with lower resource throughput. So there needs to be the technology context, the well-being context, end use policy instruments, and of course the link to climate mitigation pathways. We know that these strategies are key. I mentioned this several times before, and the reason is that the sustainability challenges are so pressing that we really need to investigate all decoupling options across the energy service cascade, not only focusing on renewable energy or other supply side strategies, but really looking across the board. And own research here has shown this. We have made a decoupling study for the global steel industry. It's interesting, the materials are in the middle of the energy service cascade. Steel, for example. Steel is neither a direct contributor to well-being, nor is it a direct driver of environmental impacts because it could be recycled and so on, and it could be used highly efficiently. So we link the steel to well-being here as a proxy using stock levels, and we link it to environmental impacts via energy and energy carriers and so on. And we study all these decoupling strategies. So we see here different decoupling wedges from the top baseline, the blue line, down to a reduction scenario where we have energy and material efficiency in industry, the supply side solutions. But we also have the lightweighting that would be improved solution, lifetime extension, reuse. This could be a shift or maybe even a void solution, and more intense use of products. That's a lot of efficiency, but also sufficiency, avoid solutions. So the demand side solutions that can really bring down emissions to levels that are roughly compatible with the 2 degrees Celsius target, which is shown here by that the red bottom line curve reaches the yellow and green temperature ranges when we take the steel sector as a constant fraction of global emissions. The IEA also has addressed demand side solution, and not surprisingly, they find the largest potential in advanced economies because they have this huge consumption in the categories of rebound goods, habitual consumption, and needs and wants, and luxury consumption. If we reduce those by a number of strategies, low car cities, reduced SUV use, less business flights and so on, improved space cooling, so you see a lot of avoid, shift, and improve measures, there could be a substantial reduction in energy use up to 9 gigajoule per capita and year. But of course, this only mostly applies to the global north countries that are the high consuming countries. Another case studies that we did for Germany showed that we can combine supply and demand solutions to actually substantially reduce emissions by up to 50% in buildings and vehicles only by looking at circular economy options, but the whole spectrum, narrow, slow, and close. So here we see that it's the efficiency strategies, the higher yields, the longer use, the material substitution that works, but also the demand side solution, the car sharing, the ride sharing, the more intense use. All of this is needed to bring down emissions further. So we can say that lifting these efficiency, material efficiency solutions, the demand side solutions to the same provenance level as energy efficiency actually increases the feasibility of ambitious climate change mitigation. And we need those demand side solutions here next to supply side solutions to do this. There's also a lot of examples from selected behavioral changes that I want to list here at the end of this lecture, but you see they're mostly global north examples. The global south examples are highlighted, but they're very few. There's one from Jakarta on cycling. The rest, you see there's low emission zones, there is pollution measures, and in the case there's also flight behavior. Natural gas demand can be addressed. So a lot of things are possible. They could also be studied in terms of their potential, and they can also be applied in other countries. And we see here that energy demand policies are not fancy talking anymore. They are actually in place. Also in global south countries, if you look at India, for example, India has now minimum energy performance standards for motors. We have a few other examples from other countries as well that are actually addressing the demand policy here for industry, but also transport. India here again, fuel economy standards is happening. Some Southeast Asian countries are also looking into zero emissions vehicles, as well as Latin America does the too. And we have also building policies in India, in China, in the Middle East, and also in some African countries. So we see that this energy demand is being addressed, but of course more could be done. One could study the effects of different urban structures to facilitate avoid solutions, for example. And this brings us back to the beginning of our lecture. We need to study the inequality. Most policies and most studies so far look at per capita averages, but we need to understand which socioeconomic groups consume how much. Where do we have a lack of services, a lack of well-being? Where do we have excess consumption according to sustainability standards? How do these people live? How could they change? Do they need different infrastructure? Which measures, the economic or regulatory measures, could be effective, which couldn't? All of this needs to be studied to also understand how the inequality dimension actually drives consumption and how inequality can be transformed, often also reduced in the future, to lower the incentives for higher consumption. This is the topic of social metabolic inequality research, and it's tightly linked to addressing the demand side of and the people-centered sustainability in the transformation next to supply side measures. Thank you for your attention.